Okay, so we discussed in our earlier recording what we were going to talk about energy transformations, correct? We talked about things in the house that transform energy, and we discussed, a battery. A battery, who remembers what type of energy a battery is? Raise your hand if you know the answer. Anderson, what type? Chemical. Elliot, is there another form of energy that this week? Yeah, it could technically be electrical energy as well. We could say that. So what we're going to do, I'm going to have you all first draw a sketch, and here's what we have. We have a battery. We have our wiring. One for which side? How many sides are there to a battery? Go ahead, Elliot. Two. Anson, do you remember the names of those sides? What does every battery have? Volts. It has volts. But remember the two sides? The two sides of a battery? You did it on your experiment for 4-H? One is negative, one is positive. So what we'll do, these have clamps. I thought it would make it easier. So what you can do is just clamp this on to your positive or negative terminal. And then we can touch it with this. So what you're going to do, you got your own pieces of paper, so I want each of you, you're going to work together, and you're going to draw out a sketch that would give the battery, your two wires, and this light bulb. Look at this. So once you have a sketch that works, talk it over among each other, draw your sketch, and then you're going to test your sketch and make sure that it works. So what is a circuit anyway? So basically we can look at a circuit, if this is going to help, as a circle, okay? It's going to go through many different things, but it all has to end up. So if we start at a battery, at the source, we'll start on one side or the other, positive or negative, and then you will go to the component I'm asking you to, which at this point is the light bulb, and then you go from that light bulb back to your battery. That's a simple circuit. You two can work together. You can just make a small drawing, and then we'll see what you come up with. Okay. Now, how are your wires going to run? Where's your wires going to go? Elliot? You two can work together and bounce ideas off each other. That's what I would suggest. Or if you want to draw each and then question each other.
Yeah, and we're going to talk.
Okay.
I don't know.
All right. Let's see yours. Where you at? Okay, so explain to me and Elliot what you have going on here.
I made two wires connected to the light bulb.
Okay, so both wires are going to the light bulb? Okay. Elliot, what do you have? To each other. But how many do you have going to the light bulb? One. So would that create the circuit that you need? If we go from one positive, how do we get back to the negative? Okay, you two talk it over amongst yourselves here. Show each other your drawings, and then let's determine which one we think is going to work the best. Okay? So maybe take two and make one. I think you're very close. We're getting very close. Okay? Just let's just do a line drawing. You don't have to draw the battery. Let's just make a circle and show me where you would put your wires. I think that's the easiest way to do your circuit. Now place your battery source in there somewhere, and then you'll place your light source. Okay.
We decided to try
Okay.
Ellie's first. Yeah.
You're going to try Ellie's first?
Yeah.
Okay.
Next to the water.
Well, this will probably take two of you, so let's test out your theories here. Somebody, you all can hook your cables up to the battery. Follow your sketch, though. I want you to follow your sketch, not what you think. Only follow your sketch. No, follow your sketches. So you have both wires connected.
Like, where do I put this red one? Yeah. Where do I put it?
Okay. There's your bulb.
Where's the light bulb?
Right there. Right there in front of you. Okay. That's good, Ellie.
Where do I put it? Light bulb, Ellie. Where do you want it?
How are we doing?
We don't know where to put it on the wall.
Okay. It's not going to clamp. You're just going to have to hold it to it. One of you hold the light bulb, and the other try to touch it. Ellie, it's not going to clamp. All you got to do is touch it. It's metal. Touch it to it. Okay. Anston, do you understand why that's not working? What are you missing on your circuit? You have, try your drawing, and let's see. I think it's going to be a combination. So, okay. So now you have
I need both of them.
positive and negative hooked up. Okay. It's going to take two people to hold. Okay.
We did it!
Okay.
Hold up.
Let's see it, Ellie. Let's see what happens. Okay. Now you've made. So what is the answer here then?
We need two. We need positive and negative.
Okay, so while we're doing that, let's take a look. So we've turned, what did we start with? What type of energy? Elliot, what type of energy did we start with? What was the battery? No, what type of energy? I'm asking. We talked about it in the beginning. What type of energy, Anston? Speak up so they can hear that. Chemical energy, and then it ran through the wires as what type of energy? Elliot, you just said it. Electrical energy. And how did it come out? Radiant energy in the light bulb. And what is it? Also another one that most lights emit. What type of energy other than radiant?
Electric?
No.
Thermal?
Thermal energy because it becomes hot, correct? Okay. So that's one form of energy transformation. So now I'm going to give you these worksheets, and we're going to watch a short video. As we watch the video, you put those down. As we watch the video, I want you to fill out your worksheets by what the video is showing here. So this is going to be energy transformation at a coal power plant, and it's going to give us different forms. So here we go. Pay attention and fill in as we go.
Welcome to MechanismAlarm.com's educational video series. Half of the world's electricity is generated by coal power plants, and there are close to 3,000 large coal power plants around the world. In this video, we're going to show you how these controversial yet indispensable power plants work. The idea behind the power plant in this video is to show you how to convert energy stored in the coal to electricity. To increase burning efficiency, a powdered coal and air mixture enters the furnace. During the burning process, the chemical energy stored in the coal is released as heat to create high temperatures inside the furnace. This heat passes to the water inside the coils located in the furnace. The hot water is then forced to move to the boiler, where it evaporates and generates high-pressure steam. The high-pressure steam is taken to the steam turbine, and the energy is...
Okay, let's start with your boiler. We see right here, this is her boiler. This is what takes the water and turns into steam. It'll be down here. Okay, that's your very start of your process, is the boiler. Okay? Then it's going to turn up. So let's also go down to your questions down here. What type of fuels are burned to produce heat energy? What are we talking about here?
Coal.
Coal. Okay? So let's fill in the blank for coal, Elliot. Fuels such as coal. Read. Follow along. Follow along. Fuels such as coal. Coal is going to be what? Chemical energy turned into what type of energy? Produce. Let's use what they have in the word bank down there. Heat. Heat will be your next answer. Okay? Number 2, we have heat energy makes the water boil to produce. Let's listen so we find out. What did she say?
Inside the steam is converted to mechanical energy.
No. Before that, what type of energy?
Steam.
Steam. Steam. Okay? Steam drives the, let's listen to C. Here we go.
This mechanical energy is then transferred to the generator, where it will be converted to electricity. The generated electricity is finally transferred to the grid through a transformer and is ready to be consumed by the public.
So let's go back just a little.
And energy is then transferred to the generator, where it will be converted to electricity.
Just a little.
Pressure steam is taken to the steam turbine.
Okay, the steam is taken.
To the steam turbine. Pressure steam is taken to the steam.
So where is the steam taken to?
Steam turbine.
The turbine. Okay, Elliot, do you see that?
Oh.
Steam turbine. So steam drives the turbine. Okay, that's it. Okay, making it move. The spinning turbine turns a generator. We're down here. Steam drives the turbine. And then, where are we at? The spinning turbine turns a generator, which produces what? Ellen, next question down. The spinning turbine turns a generator, correct? That's what she just said. Write that down. Here's the word down here if you need help spell. And the generator turns that energy into what? Look at your word bank. Electricity. Good job, Elliot. Good job. And then that electricity is sent to, look at your word bank, our homes. So what we have is the chemical energy when it changes the state of coal burning, produces steam, produces heat, which produces steam energy, which produces, when it turns the turbine, that is kinetic or motion, we could say energy, and then that produces electrical energy, which is sent to our house. So a bunch of energy transformations, correct? All right. So we know now that all those transformations take place, and then they come into our house, and they do what again? What do they do again? They transform one more time, correct? Because we transform electrical energy, we use our kinetic energy or our motion, and we create radiant thermal and more kinetic energy, correct? So even though it's so that many transformations of electricity just to get to our house, and then we transform it ourselves here. Okay? That's it for today.